In this video, we will solve scenarios using unit rate. So in the last one, I said we were going to get to rates, unit rates, oh my, or ratios, rates, unit rates, oh my, but we never got to it. So I wanted to make another video to explain at least those three tables that we saw, or two tables we saw near the end. So this video just looks at the tables that were on the back page of that sheet, and we started class with a see, think, wonder kind of activity, meaning like we're just going to see what kind of pattern we might see going on here, think about how it might relate, and wonder how would we continue that pattern throughout the rest of the table. So I noticed right away that this is similar to the hiker, backpack, and total weight activity. Let's think we have our distance run, we have our distance biked, and then we also have our total of exercise miles. So I am, and I also know that we're talking about ratios. So I know that there is a multiplicative, right? The ratio of number of miles run to the number of miles biked is equivalent for each row. So I'm looking for that multiplicative relationship, and I know it has to be consistent throughout each row because, well, they tell me it has to be. But I'm going to also determine if that's the case myself. Okay, so I want to first see, how do I get from 3.5 to 7? And many of us sort of got stuck here thinking, okay, so how do I go from 3.5 to 7? Well, one thing we can do in our calculator is to just plug in 7 divided by 3. And again, this fraction we can make into a decimal and 5/10. We also have those calculators that deal with fractions. So we would use our unit button to figure out how to do the half, or the whole number, and also the other buttons for numerator and denominator. So I know I plugged that in my calculator. I know that 7 divided by 3.5 would give me 2. So that means that each time, because this is equivalent, it's being multiplied by 2. So then I go down here, and I know I have to multiply this by 2 to determine how many, miles biked would be, or the distance from the miles biked for this category. So I'm going to write 1 and 1/2, and instead of me plugging it in my calculator, I'm just going to use what I know about multiplying by decimals, or rather fractions, that I'm going to first multiply my whole number by 2 and get 2. And then multiply 2 by my numerator. So 1 times 2 would give me 2. And now I have 2 and 2/8. So I'm going to plug that in here. And now I want to work backwards, right? I'm going to use the inverse of multiplication to go from to go from back to run, bike to run. All right, so let me change the color. I'm going to change it to blue because I'm going backwards. So I want to divide now by 2. And 5 divided by 2 would give me 2.5. And I have all of this filled up until this one right here, right? And this was the one we had to determine a separate unit rate or separate relationship to answer this one. So that's, we're going to wait for last. So now let's go ahead and add up. I guess I'll go to black here. I have 3.5 plus 7. I could write 10, right? 7 plus 3 would give me 10.5. Or I could keep the decimal and have 10.5. Either is correct. Here I have the decimal, so I'm going to have 7.5. And here I am going to, because my denominators are the same, right? 8 are my denominators. I can add my two whole numbers, 1 plus 2, and get 3. And then add my two numerators, 1 plus 2, and get 3. And my denominator stays the same. So now let's see, I'm going to change my color to green because I want to determine a separate relationship, a separate multiplicative relationship between 7 and 10.5. So here I'm going to put that in my calculator. I'm going to do 10.5. Notice I changed that to a decimal. And I'm going to divide that by 7. So I'm going to do that now. And I get 1.5. Now I want to see if my pattern is the same. So let me try another one here. So I have 7.5, and I'm going to divide that by 5. Yep, I get 1.5. Okay, so we're noticing a consistent pattern on this side as well, which would make sense. So now we can go to this top row where before we were sort of stuck because we didn't know the mouse run or the mouse bite, but we do know the total. So I'm now going to take that total, which is 6, and divide that by this new sort of, we've been calling it the magic number, by this new number, 1.5. And we now have 4. So in this situation, we could do two things. We could say, what would add up? What number could I put here that when added to 4 would give me 6? Or I could divide 4 by 2 because I have this relationship right here. Both strategies would work. So let's try dividing by 2. 4 divided by 2 is 2. And then we also know that 2 plus 4 would give us 6. So let's try one more. Now this one was a little bit more tricky just because I know that the second row we had a crazy little decimal that we didn't like, but that's okay. So here we have a ratio of milk to flour. They're making biscuits, and for every 2 cups of milk there are 3 cups of flour. So I'm going to start with this row, and the reason why I like to start with this row is because everything is given. I have my 8 for my milk, I have 12 for flour, and I know I need my total, so I could just right away, and I'll just change the color to black, add that to get 8 or 20, right? I just added 8 plus 12. Now I want to figure out that relationship, multiplying or dividing, to get from 8 to 12. So in my calculator, I would do 12 divided by 8. And I'm just going to write that right here so you see it. 12 divided by 8. And again, like similar to the last problem, I have a ratio, or rather a rate of 1.5. Keep selecting that button. So now I want to use that again. So now we have 1.5 times 2.5 and get 3.5. All right, so now let's see, where do I get that 1.5 from? So we have this tape diagram here, and I am going to try to make this work. I have my milk and I have my flour. So my milk is half and my flour is 1, 2, 3, 3 parts. Yep, this is going to work. So then I cut this in half, right? So for every 1 thing of milk, we have 1.5 of flour. Okay, so that's where you see our unit rate right here in our tape diagram. All right, so now let's see. Now we're going to work our way backwards. We're going to use this 1.5, and I'm going to change it to blue, and I want to go back. So here I divide 4.5 by 1.5, and my answer is 3. Okay. Now I'm going to add these up. 3 plus 4.5 gives me 7.5. 2.5 or 5 tenths and 3 75/100ths would give me, if I add those two up, 6 25/100ths. I remember when I won't name anyone by name, said gave it the correct decimal, and I was like, yes, we're calling them by our decimal name. So now we're going backwards, right? So we're trying to figure out or determine this new relationship between the total cups to just the flour. I mean, there's another one to milk, but let's figure out to flour. So I like to divide it like this. And next time I'll make sure our sheets have this extra little column in it so that we can clearly see what that sort of that constant ratio or rate that we're using is in between there. All right, so I have for every 7.5, there are 4.5 cups of flour. So I'm going to do 7.5 divided by 4.5. And this is where people did not like the number, right? We got a repeating decimal. And if we just look at this 6666667, we know that that is 1 2/3. And we might not be familiar with it, but we will in time recognize that as, okay, that's just 2/3. So we're now dividing by 2/3 or multiplying by 2/3. Okay, so I have this 12.5, and I am now going to use this new rate, right, from total to cups to flour, and divide that by 12, 1 2/3. And I get 7.5. Right? So the same thing applies here. I could do two things. I could figure out what number I could add up to 7.5 to get 12, or add to 7.5 to get 12.5. Or I could divide this, right? I'll change it to blue. Divide this by 1.5 to figure out what this other number is. And I'll just do that for time being, and we'll double check. We get 5. And so it is true. 5 plus 7 gives me 12, and 0, well, it's probably not the best way to do it, but 5 plus 0 gives me 5.5. So that definitely adds up.